So up to now, what we get? We get a component of force. Okay, component of force in three directions: x, y, z. Okay, component of force in components of force in three axes: x, y, and z. Okay, and what are those components? X component is dpx by dt, where dpx by dt is the rate of change of momentum along x direction, or we can write this as mx, or fy equal to dpy by dt my, and z component is ddt of dz, or you can write this a z. Okay, where x, ay, z are components of acceleration. Px, py, pz are the components of momentum along x, y, and z direction. Okay, so this is how we resolve force in the three axes or three components. Okay, now the second point, important point for Newton's second law. The second point says that if the force is not parallel to the velocity means velocity of the object, then the force will affect only that component of velocity which is along the direction of force. Okay, so what does the second point, important point for Newton's second law says that if the force is not parallel to the velocity of the object, then the force will affect only that component of velocity which is along the direction of force. Okay, and the normal component, okay, and the component of velocity which is normal to force will remain unchanged. Okay, and next thing is, this is the first one, and secondly what it says, the component of velocity normal to the force remains unchanged. Okay, so as an example we will understand this. Suppose there is an object of mass m. We have projected this object with velocity v at an angle theta with the horizontal. Okay, suppose this is x, this is y. We have an object of mass m. We have projected or throw it with an initial velocity v along a direction theta, along direction theta along theta with the theta is what? Is the angle between the direction of velocity and the horizontal. Okay, object m is projected with a velocity v along a direction theta with x-axis. So suppose, what will be the components of vx of v along x and y axis? Suppose this is vx and this is vy, y-axis, and this is x. Okay, but the component of v, how we represent v? V equal to vx I cap plus vy j cap. Okay, this is how we represent v. So component of v along x and y axis are vx I cap and vy j cap, or vx is the x component, vy is the y component. of the velocity of the object. Okay, now one more thing is that when suppose it is every object on Earth experiences a gravitational force. Okay, Fg. Every object in Earth or any planet experiences a gravitational force due to the planet or Earth. Okay, every Earth object in Earth experiences a gravitational force. We know this, which is represented by a physical mg. Mg is the acceleration due to gravity, which is 9.8 Newton, or in dyne 980 dyne. We say every object on Earth experiences acceleration due to gravity, which is 9.8 Newton. Okay, and the mass of the object. So when we project an object or throw an object like this, it will also experience a gravitational pull. Okay, gravitational pull along downward direction. Okay, so what will happen? So due to this gravitational pull, there is a change in the velocity will take place. Okay, but this gravitational force, but if we consider if we look at the point we have discussed, it says that it will experience the force. If the force, this is a component of, if the force and velocity are not in same direction, then the force will affect only that component which is along the direction of force. Okay, so see I am writing like this clearly. See, this is the Vx component and this is the Vy component of this velocity v, and gravitational pull is in this direction. Okay, and g. Okay, mass. Okay. So this gravitational force Fg, okay, Fg will affect only Vy component of the velocity. Okay, Vx component, which is normal to the gravitational force, will remain unchanged. Okay, so from according to this point, important point, what we see that Fg will only affect the Vy component. Okay, and Vx component will remain unchanged, or Vx component has no effect of gravity. Okay, so this is the second point. Okay, so suppose if we try to evaluate the direction of motion along perpendicular direction, then we have to consider the acceleration due to gravity g. Okay, if you consider the direction of motion along y-axis, we have to consider acceleration due to gravity along the velocity vy. But in case of vx, if we consider horizontal direction, there is no term g will come. Okay, in this direction, if we try to evaluate the direction of motion, there is no component or there is no term like acceleration due to gravity or g. Okay, it will affect only this component, this force, gravitational force will affect only that component which is along this, which component is along this force. Okay, so Vy is along the direction of gravitational force, so this force or this acceleration will only affect this component of velocity, and other component which is normal to the direction of force will remain unchanged, or this force will not affect the component which is normal to the direction of the force. So this is the second point states actually. Now the third point. So the third point I will discuss with an example. What is the third point? Suppose it is an object of mass m. Suppose m is equal to 5 kg. Okay. On the left side you experience a force 10 Newton. Suppose it is plus. On the right side you experience a force equal to 5 Newton. So if you are asked to acceleration of this object, acceleration of mass m due to this to force, what we do? First, we go for the net external force, F net. See, in case of when I deal with the force acceleration or acceleration thing in mechanics, we see the net acceleration, net external force. When we go for acceleration, we see the net force or resultant force experienced by the body. So net force will be 10 Newton minus 5 Newton, and direct subtracting because those are just opposite direction. So it will be 5 Newton along which direction? Along F1 direction. So what will be the acceleration? Will be F net by m. So it will be 5 meter per second square along F1. So this body will experience acceleration this direction, which is 5 meter per second square. Okay. So the third one says that when you go for acceleration, go for deriving acceleration or go for calculating acceleration on a body, you see where multiple forces are acted on different directions. Then we go for calculating acceleration, we go for net force. Okay. When a body experiences multiple forces in different directions, for calculating acceleration of that body, we go for resultant force. Okay, this is the third point says. Okay, these are some important points regarding the Newton's second law. Now we go for some examples. Okay, the first example is which is related to Newton's second law. Okay, suppose there is a bullet. Suppose there is a bullet of mass and 0.04 kg is fired which have initial orbital velocity. What is the velocity of the bullet? 90 meter per second. And strike a wooden piece of wood. Okay, thick piece of wood and fires through 60 centimeter. Okay, we have to find the resistive force. By bullet. How much resistive force is experienced by the bullet? We have to calculate. The question is, we have fired a bullet which has velocity 90 meter per second. The mass of the bullet is 0.04 kg, and strike a wooden piece or wooden box. Wooden piece of wood. And what happened after striking? It gets fires through the piece of wood. 60 fires to 60 centimeter through the piece of wood. Okay, it gets fires up to 60 centimeter inside the wood. Okay, so we have to find the resistive force. Okay, see, when the bullet strike this piece of wood, it will experience a resistive force. Okay, due to this resistive force, the bullet gets stopped after traveling or after passing 60 centimeter in the piece of wood. So we have to find that amount. What amount of force the bullet get experienced? So what we do? Suppose this position is A, this is B. Okay. So bullet is fired at 90 meters per second. So what is the velocity of bullet at position A? Suppose its initial velocity is 90 meters per second. Okay. At point B, the bullet gets stopped. Okay. So the final velocity of bullet at point B, this final velocity where the bullet gets stopped. This is 0 meters per second. And this is the distance traveled by bullet. Okay, after striking the piece of wood. What is distance? 6 centimeter, 60 centimeter, 0.6 meter. Okay, so we have to find the acceleration. Okay, force means acceleration. So we could first to find the acceleration. What is the acceleration of the bullet during the pass from A to B? Okay, see in the motionless straight line we got a relation that v square minus e square equal to twice a square. Use the final velocity, use the initial velocity as the distance traveled. What is the acceleration of the body? So here v is 0 and u is 19 meters per second. A we have to calculate, s is given 0.6 meter. So now putting the values we get a is equal to minus u squared by 2s. So u is 90, 2 into 0.90 squared, 0.6 meter. Okay. So if we when it is minus, if we calculate this, how much it will be? Minus 6750 meter per second square. So this is the acceleration or retardation. Acceleration means it is negative acceleration. Okay, because the bullet gets stopped. Okay, velocity of bullet get decreased, or the from point A to point B, after reaching point B the velocity of bullet becomes 0. So retardation or deceleration takes place during the pass. Okay, so this is negative. Okay, acceleration is positive and deceleration, retardation is denoted by negative of acceleration. Okay, so that's why the negative sign arises. Okay, so what is the amount of acceleration? This amount of acceleration or this amount of retardation takes place during this pass. Okay, now we have to calculate the force. Okay, so I'm having this is the deceleration. So what is the force experienced by a bullet? The force is mass into given force into acceleration. 6750. Okay, is Newton. So how much it will be? It will be 270 Newton. Okay. So what is the force experienced by a bullet due to this collision, or due to or what is the force experienced by a bullet during this pass? This is 270 Newton. So this 270 Newton resistive force is required to stop the bullet by this piece of wood. Okay. So this is how we calculate the resistive force. This is just an example which can be solved by using simply Newton's second law. Now next example I am taking, suppose example number 2. Suppose a body of mass m is equal to, suppose it is 5 kg. A body of mass 5 kg is experienced two force acted upon this body. What are the force? F1 and F1 is how much? This 12 Newton, or F2 is 16 Newton. Okay. The body of mass m experiences two forces which are perpendicular to each other. Okay. The forces are F1 is 12 Newton and F2 which is 16 Newton along x direction and y direction. 12 Newton force is experienced by this mass. Okay. Now we have to find the acceleration. Okay. Acceleration means acceleration vector. Okay. So we have to find the magnitude and direction of acceleration. Okay, we have to find the magnitude direction of acceleration due to these two forces. Okay, so what we do? See, when finding the acceleration, when multiple forces or when more than one number of forces is applied on a body, for that, in that case, to find the acceleration, we will take the resultant force. Okay, so we simply consider this is F1 vector and this is F2 vector. Okay, so the resultant will be in this direction, suppose F. Okay, so resultant of these two forces will be how much, since they are in perpendicular to each other. So F1 square plus F2 square, and it will be, sorry, okay, I'm taking down the magnitude. Okay, so how much, 12 square plus 16 square. Okay, 144 to 56. So it will be 0, 0, 4. So it will be 20 Newton. Okay, so the resultant force will be 20 Newton. Okay, suppose this is the resultant force, F is equal to 20 Newton. See, this is the magnitude of force. Again, we have to calculate direction also. So we get F equal to 20 Newton direction, 20 Newton force. This is the resultant. Okay, so what will be the acceleration of this body? Acceleration is equal to F by m. Okay, mass is 5 kg. Sorry, 5. This is mass 5. 20 by 5 is equal to 4 meter per second. So acceleration experienced by this body is, the magnitude of the acceleration experienced by the body is 4 meter by second square. And this acceleration arises because of these two forces. Okay, because of these two forces, this amount of acceleration is experienced by this body. Now we have to find the direction. This is the magnitude. Okay, so magnitude of acceleration is 4 meter per second square. Now I have to go for direction. Okay, suppose this theta. Okay, suppose this resultant component is making an angle theta with the F2 force. Okay, the resultant force is 20 Newton is making an angle theta with the force F2. So what will be the cos theta? Okay, what will be cos theta? Suppose if we join this, consider this O, P, Q. So cos theta will be how much? OP by OQ. So OP means what? 16 Newton, and OQ means 20 Newton. So how much it will be? 4 by 5. Okay, so theta will be cos inverse 4 by 5. Okay, or cos inverse 0.8. By using scientific calculator, you can easily calculate how much angle will cos inverse 0.8. Okay, so we get direction. Now what is the direction? Theta is equal to cos inverse 0.8. Okay, so we are asked to calculate the magnitude and direction of acceleration. So what is the magnitude of acceleration? Acceleration is 4 meter per second square, and direction of acceleration is how much? How will we write this? Direction of acceleration is, or we can write is the acceleration is 4 meter per second square. Okay, and it makes an angle of how much? Cos inverse 0.8. Cos inverse which force? We have to mention this, which F2 force. So how we represent the result? The acceleration, the magnitude of acceleration is 4 meter per second square, and it makes the angle of cos inverse 0.8, which F2 force. Okay, so this is how we calculate the magnitude of acceleration, the magnitude of direction of acceleration in this case. Okay, the magnitude of acceleration is 4 meter per second square, and this acceleration makes an angle of cos inverse 0.8 with F2 force. Okay, and cos inverse 0.8, you can easily calculate the angle, how much angle will be cos inverse 0.8 using scientific calculator. Okay, so this is how we calculate the direction, magnitude direction for a force. Okay, now next thing is impulse. We'll discuss. Okay, impulse is nothing but change in momentum, which is represented by time. Okay, this thing we'll discuss in the next class actually. For now, after this I'll stop. Okay.